Hi students, I am Prashant B. Chandran, Assistant Professor, Automobile Engineering Department, SNIT Adoor. Okay, in this video, I am discussing you about these portions in our sixth module, that is welding. The portions are gas welding, fluxes used in gas welding equipment, fluxes used in gas welding, filler rods, arc welding equipment, and electrodes used in arc welding. First of all, gas welding equipment. Okay, you can see the various components in a gas welding equipment. That is, there are two cylinders. One is an acetylene cylinder, and another one is an oxygen cylinder. Both these cylinders have regulators. Okay, and there is a welding torch. The welding torch has two hoses which are connected. One of the hose is connected to the acetylene cylinder, and another one is connected to the oxygen cylinder. To control the flow of both these gases, there are regulating valves, etc. And there is a torch tip also. Okay, and can discuss one by one. First of all, oxygen gas cylinder, that is solid cylinder made of a solid cylinder which is made up of mild steel or alloy steel painted in black is the oxygen cylinder. The cylinder needs to be kept upright always. That is, cylinder should be always be kept upright only. It is provided with a pressure regulator and appropriate safety measures also. Oxygen is stored at high pressure inside the cylinder. The pressure regulator helps in supplying oxygen at regulated pressure for the welding purpose. That is, pressure regulator used to supply oxygen at required pressure for our welding purpose. The second component is acetylene gas cylinder. This acetylene gas cylinder is also a solid steel cylinder but painted mostly in maroon color in order to identify easily. Okay, due to safety reasons also, it is to be kept upright always. Okay. In addition, there are several safety measures provided in this cylinder. The gas is kept at a high pressure inside the cylinder. A pressure regulator attached to the cylinder is used to reduce the pressure and regulate supply of acetylene gas for welding. Okay. Then connecting hoses. Blue colored hoses are used for oxygen gas and red colored hoses are used for acetylene gas supplied to the welding torch. The hoses used here should be strong. It should be non-porous and flexible. Usually rubber hoses reinforced with canvas are preferred for this purpose. Okay. The fourth component is welding torch. From the pressure regulators on the cylinders, the gases are carried to the welding torch through the hoses. Okay. That is, from these both these cylinders, the gases enters the welding torch. The pressure regulators supply the gases to reduce the pressures, and the welding torch mixes and controls the flow of gases to the welding nozzle. Okay. As the gas mixture comes out of the torch tip, it is ignited to produce a flame for the welding purpose. The welding torch is also called as blow pipe. Another name of welding torch is blow pipe. Both oxygen and acetylene are fed to the torch at equal pressures and are mixed prior to being fed to the nozzle tip. The welding nozzle enables the welder to guide the flame and direct it towards the welding spot easily. Okay, this is the purpose of welding torch. You can see the welding torch clearly in this diagram. There are two openings, that is one for acetylene hose and another one for oxygen hose. Both of them enters into this nozzle, and their pressures can be controlled by valves. Then there is a mixture, and from the mixture, the mixed gas enters the nozzle tip where it can be burned. Okay. Next, filler material. Okay. Filler materials are additional material that is usually added to the weld pool to help filling the weld joint. Okay. These materials are called as filler material. The filler material welds due to the heat of welding and forms an integral part of the weld joint. This is the main function of filler material. Filler materials are made up of the same metal or compatible metals as that of the base metal. Okay. It is generally available in the form of small rods which are called filler rods. The filler rods are available in various sizes ranging from 1.5 mm to 6.3 mm diameter and are selected depending on the thickness of the base metal. Okay, that's all about filler material or filler metal. Then fluxes. When the metals are heated or melted in air, atmospheric oxygen combines with the metal to form oxides. That is, oxidation will happen while the time of welding. Formation of oxides results in poor quality welds and it needs to be prevented. Flux is the material used to prevent and retard oxidation of metal surface. That is, the function of flux is to prevent the oxidation process. Okay. The flux is a fusible material and it is generated and it generates a gaseous shield around the weld zone and hence reduces the chances of oxidation. That is, during welding, this flux will create a shield or an envelope which protects the weld from being in contact with the atmospheric oxygen. Okay, that is the purpose of this flux. If some oxides are formed, the flux reacts with the oxides and a slag is formed which floats above the molten metal and protects it from further oxidation. Okay. Flux is available in powder, paste or liquid form. It can be applied directly onto the surface of the base metal or the heated end of filler is dipped into the flux. Now fluxes are used while welding steel. Okay, for welding steel fluxes are not used, but for stainless steel, cast iron, aluminum, copper and other alloys suitable fluxes are used. Some of the commonly used ingredients of fluxes are borax, boric acid, lime, magnesium silicate, sodium chloride, potassium fluoride, etc. Okay. Then arc welding. Okay. That is, we have already studied about gas welding. The next topic is arc welding. That is, an arc is produced here. That is, it is a type of fusion welding process, whereas the coalescence is produced by heating with an electric arc with or without the use of filler metal and mostly without application of pressure. Here pressure is not required. There are many different types of arc welding process in use. The appropriate one is selected based on the base metal dimensions, type of joint, weld position, quality of metal and many other factors. Following are some type of arc welding methods. That is shielded metal arc welding SMAW, submerged arc welding SAW, metal inert gas welding MIG, then tungsten inert gas welding TIG, plasma arc welding PAW, etc. Okay. That is, in an arc welding, an electric arc is produced and due to the heat produced by this arc, welding process is done. That is the process. Then arc welding equipment. There are welding process. The arc welding processes needs a source of electric power. This can be of alternating current AC or direct current DC type. In AC machines, transformers are used to provide the power supply, while in DC machines, a transformer with a rectifier is used to produce the DC power as per needs of the welding process. But there are three types of polarities given. That is, first one is DC straight polarity, that is direct current straight polarity. Second one is DC reverse polarity, that is direct current reverse polarity. And the third one is AC, that is alternating current. Okay. Then electrodes, that is before going to electrons. The DC arc welding is generally preferred because it provides better control of heat input. Okay, mostly we use DC arc welding because the control is easy. In DC arc welding, about 70% of heat is liberated near the positive terminal, that is anode. While using DC, the electrode can be connected to the negative terminal cathode and workpiece to the positive terminal. This arrangement is called straight polarity or direct polarity or DCSP. Okay. While using thinner materials, the polarity can be reversed and the electrode can be made positive, that is anode. This arrangement is called reverse polarity or DCRP. Thus, here the depth of penetration will be smaller. Then, when using AC for welding, polarities keep on changing continuously. As a result, depth of penetration will be somewhere between the DCSP and DCRP modes. This is true only when other parameters like voltage, current, electrode diameter and arc length are kept constant. A voltage of 40 to 50 volt is needed to start an arc, and for continuous welding 20 to 30 volt is enough. The current rating is in the range of 150 to 800 ampere. Okay, it's the current rating. Then electrodes. That is welding electrodes. In general, there are two types of electrodes used in electric arc welding process, that is consumable and non-consumable electrodes. Most of the arc welding processes make use of consumable type electrodes. Among this, the electrodes can be continuous or stick type, bare or flux coated, and of various sizes. The function of electrode is to provide heat input in arc welding process. When the electrode is consumable, it also supplies filler metal to the weld pool by melting its tip. Once the arc is initiated, the electrode is continuously consumed and hence it should be removed continuously towards the workpiece in order to maintain the arc at a constant length. Consumable electrodes are made of materials like steel, cast iron, copper, brass, bronze or aluminum to suit various metals to be welded. Non-consumable electrodes. Non-consumable electrodes are made up of carbon, graphite or tungsten and are also used in arc welding. The carbon and graphite electrodes are used in DC welding only, while tungsten is used for both AC and DC welding processes. Here the filler material is provided by a separate filler rod. Hence it is not easy to control the heat input and the amount of filler material deposited separately. Then the main functions of flux electrode coating are: first one, when heated, the coatings give off gases like carbon dioxide, which acts as a shielding around the molten metal and protects it from contamination by oxygen, hydrogen and nitrogen from atmosphere. That is, it helps to prevent the oxidation. Second one, the oxide based fluxes upon melting mixes with the oxides and other impurities present in the molten metal and form a slag. Since the slag is lighter than molten metal, it floats on the top of the metal and protects it from further oxidation. The slag also helps in reducing cooling rate of molten metal. Okay. The third one, the coating also contains materials to make the slag viscous. The slag should be viscous, and this would be helpful in making welds in vertical positions, okay, to cover the weld pool for a longer period of time. Fourth one, some elements which support arc stabilization are also included in coatings in electrodes. Next one, some alloying elements which will improve strength and physical properties of metal, welded metal, or also are introduced through the coatings. Next, by using electrodes, spattering is reduced. Okay, these are the functions of electrodes in arc welding. Thank you for watching this video. Have a nice day.